Okay, let's have a look here. Find the quadratic equations whose roots are that and that. Okay, so first we want to get the sum and then the product. So the sum is 6 and the product is 9 plus 1, which is 10. So the roots, it's going to be z squared minus the sum plus the product. Okay. Part 2, we've got a cubic and we have one of the roots. Find the value of k and find the other two roots. So it looks like here k is a real number. So the roots are, for part 2, 3 plus I and 3 minus I. So that means the quadratic that we just got previously can be divided in because it contains the two, it has the same two roots, so it's a factor. So if we divide in our quadratic z squared minus 6z plus 10 into our cubic, z cubed minus kz squared plus 22z minus 20. So first we'll have a z, and that would be z cubed minus 6z squared plus 10z, and then we subtract, they cancel. That would be minus k plus 6 z squared plus 12z minus 20. So I see that what has to be finished, it has to finish off with minus 2, because we can see at the back we're supposed to get minus 20 and we're supposed to get plus 12z. So this front piece here has to be minus 2z squared. So therefore minus k plus 6 has to equal minus 2. So that means k would equal 8 then. That's what it has to be. So I've got the roots, and the roots are 3 plus I, 3 minus I, and 2 are the roots then. 3 plus I, 3 minus I, and then 2 are the roots. Okay. Next now, we just want to solve that equation. Okay. Just my writing pad's not working. 1 second. So it's root 5 and then the modulus, so that's the square root of u squared plus v squared plus I times w, so that would be ui, and then that would be I squared v, so that's minus v. That's the equal 3 plus I. So that's root 5u squared plus 5v squared plus ui minus v equals 3 plus I. So by just comparing the imaginary parts, therefore ui has to equal I, so the u is just 1. So then looking at the real parts, if the u is 1, we get 5 plus 5v squared minus v has to equal 3. So that means root 5 plus 5v squared has to equal 3 plus v. So if I square both sides, 5 plus 5v squared has to equal 9 plus 6v plus v squared. So that means 4v squared minus 6v minus 4 has to equal 0. 2v squared minus 3v minus 2 has to equal 0. 2v, v, 2 and 1, I think. I could make a minus 4 plus 1, so 2v squared minus 4v plus v minus 3v, okay, equals 0. So the answers, v would be minus a half or 2, but u seems to be always 1, so it's 1 minus a half I or 1 plus 2I. Okay. Lastly, now use de Morgan's theorem to find the three roots. Use de Morgan's theorem to find three roots of the equation. Interesting. It only wants three roots when there's 6 roots. So we have z power 6 equals 1. Z power 6 equals, and 1 can be written as cos 360n plus I sine 360n. So power 6, I have to take the 6th root. So that will be cos 60n plus I sine 60n. So the roots would be, just put the n in from 0 to 5. So obviously when you put in 0 you get 1, which is one of them. And then you're going to have next cos 60, which is a half, plus I sine 60, which is root 3 over 2i. And then cos 120, which is minus a half, and then minus root 3 over 2i. And then what's the next one? Cos 180. So cos 180 is minus 1 and sine 180 is 0. So that's minus 1. And then now cos 240, which is minus a half. And then sine 240, which is minus root 3 over 2. I guess sorry, that's a plus root 3 over 2 earlier there. And then the last one, let's see, cos 305, no, cos 300 is a half, and then sine 300 is minus root 3 over 2i. So we'll just make sure these are right, because they all should have pairs, plus or minus pairs. So Z0 goes with Z3, and then Z1 goes with Z4, and then Z2 goes with Z5. So I've actually found all 6 rather than just 3. I'm not sure why it said to find 3 roots of the equation, where it's quite easy to get all 6 roots. Okie dokie, I think that's all okay.